Hello. In today's demo, I'm going to show you how to create a physical standby database. In this demonstration, I'm giving a simple procedure. I'm not using any RMAN commands. I'm just using a simple SQL to create a physical standby database. Now let's go into the demonstration. This is my primary server. This is my server, which is the database is to, and then this is my primary database SID, and this is my standby database SID. So now let's go into the details of how do we create a physical standby database. Before creating a physical standby database, we need to pair a primary database and primary database. So these steps are common for every procedure that you follow to create a physical standby database. I mean to say there are different ways to create a physical standby database. In this demonstration, I am using only a SQL commands to create a physical standby database. There are different approaches to create a physical standby databases, but the steps that I am showing now are common to every procedure. So let's go into in detail what are the preparatory steps. So on the primary database side, let's see. So I have my database up and running. So the first and foremost that I have to do on the primary database side is to a force logging. The force logging mode determines whether the database server logs are changed in the database, except of course for changes to the temporary table space and temporary segments. Let me talk a little more about what is a force logging. Force logging mode is recommended to ensure data consistency. What happens if that all of your redo information has to go from your primary database to your standby database? If they are not logged, then you may be losing some information from your standby logs. So as a Oracle 11G, we can do a force logging by doing a alter database force logging. Force logging actually forces the redo to be generated even when no logging operations are executed. Temporary table spaces and temporary segments are not logged. Force logging is recommended for both physical and logical standby databases. So we also recommend that you do a force logging even on your primary, because at some point your primary is going to be your standby database. So this is how so if you look in $, database, you will be able to see whether you have a force logging or not. So first let me enable force logging on the database. So this is my primary database. I'm now enabling force logging. After database, create a standby redo logs. We have online redo logs, and are going to be shipped using the remote file server, and you want to send them to your standby redo logs. The standby redo logs are used only when the database is in the standby role to store the redo received from the primary database. These standby redo logs from a separate pool of logged file that will have a separate set of numbers. So you need to configure these standby redo logs. Configuring these standby redo logs is highly recommended to aid in the role reversal. It's required to implement asynchronous transport mode at real-time apply. You must create at least one more standby redo log group that you have online redo log groups in the primary database. It needs that to help for performance. In addition, each standby redo log must be at least as large as the largest redo file you that in the redo log of the sequence database. If it cannot find the standby redo log is the same size or as large as the incoming redo log, or all standby redos of the correct size have not been archived, then the archive process will go from the standby redo logs to your archive redo logs. Having said that, let me show you how to create standby redo logs. So first I am checking how many log files that I have on primary. I have 3 log files. So I do not have any standby redo logs as of now. Now I'm going to create standby logs. This is the syntax that we use to create a standby redo files. If you see the syntax here, I am using a standby. That means we are creating a standby redo log files. I'm going to create 4 standby redo log files because I have 3 online redo log files on the primary side. To create that means. If you see the size that I considered here, I choose the same size that I have on the primary side. See here, it should be either equal or greater than the size of the redo log that I have on the primary side. So here we have 4, 5, 6, 7 is the group number, and these 4 are the standby redo logs. Let me go to the next step. The next step will be to prepare initialization parameters on the primary database side. So I have already prepared initialization parameters for primary database side. Let me show you those parameters. If you see, these are all the parameters. These are all the parameters that I'm going to set on the primary database side. These parameters, let me take a minute to explain some of the important initialization parameters that needs to be set on the primary database side for physical standby database creation. First, let me take a look at the log archive config parameter. You specify the DG config attribute to list a DB unique name for the primary database and each standby database in the data guard environment. By default, the log archive config parameter enables the database to send and receive redo. The log archive config parameter can be used to disable the sending of redo logs to remote destinations or disable the receipt of remote redo logs. If you use a v.dg config, you can see the unique database names. Now in a primary standby database scenario, database name is always the same, but the data's unique name is going to be different. When you are dealing with logical standby, the database names are usually different, but if it is a physical standby database name is the same as all on the same on all the databases. The unique name is going to be different. The next 2 important parameters are log archive dest n and log archive dest state. By using these various log archive dest n attributes, you define most of the settings of your data guard configuration. The redo transport service is directly controlled by these settings. The number of different attributes that you can set for this. Most have default that are adequate. You need at the minimum one of the following, either the location you have to specify, and coming to log archive dest state 1, you need to set this to enable. The next important set of parameters are VB file name convert, log file name convert, and standby file management. Specify these parameters when standby database have this directory structure that differ from the primary database. And also use these parameters when the primary database is transitioned to a standby database. For standby file management, you can set two values. One is auto and one is manual. This parameter is used to maintain consistency when you add or delete a data file on the primary database. So you set manual data files must be manually added to the standby database. If you set this parameter to auto, data files are automatically added to the standby database. So these are the main initialization parameters that I set on the primary data set. So we copy file to the appropriate location. I'm now copying the correct file. Now this is the correct initialization parameter file. Later when I shut down this database, I will create a file for this initialization parameter. Let me do that. I'm now verifying whether the new values have taken into effect or not. Yes. So now is up with the new initialization parameter. Now I am going to create SP file from the P. Now it is with the late times. So SP file is created. Let me start the database with a SP file. Now database is started with the SP file. So finally, let me see whether my database is in archive log mode or not. No, database is not in archive log mode. So in order to have a database working in standby mode, I need to have the database enabled for archive logging so that archives are generated and these archives are transported to the standby side. So let me enable archive logging for my. Now my database is running in archive log mode. My next step is to create listener.wara file and net service names file, which is tns name.wara file. So these files I have already configured. I'll show you the content of these files. So this is the content of listener.wara that I'm going to configure on the primary side. Actually, tns names.wara file I am configuring for both the primary side and the standby side. So the same file exists on the standby side also. So this content tns names.wara file that I'm going to create on the primary as well as on the standby side. So let me these two to the appropriate locations on the side. Let me any listener running. So listener running, let me go into the location. So now I'm copying from the files which I already configured. Now let me start the listener and verify whether it is starting properly or not. This is the listener name I used on the primary side. And let me verify the alias. So it is working fine. It says no listener because I'm yet to configure a listener on the standby. So till the point we configure the same tns names.vara on the standby side, I will not be able to ping SBI the standby side. With that, we have completed all the configuration steps that are required on the primary side. Now we need to get some of the configuration files or the data that is required from the primary side to the standby side. We need to create a control file for the standby database, and also we need to have a database backup that is to the standby side. In this demonstration, going to a cold backup. As a procedure purpose, I'm going to show you the cold backup, but there are just features available in 11G release 2. Using that, without even having the backup of the primary database, we can create a physical standby database. So that is also shown in a separate demonstration. I'll let you know. Let me show my database. This is the location where I have all my data files for the primary database. Let me copy all these files to a temporary directory from where I will copy these files to standby server. We also need to copy initialization parameter and password file to the standby site where we edit init.vara parameters specific to the standby site. So let me copy all those two files as well. Now I need to copy all these files to the standby side where I'll configure initialization parameter for the standby side, and then we can proceed with other configuration required for the standby side. Now go to my server. I'll do the configuration standby server. So let me create a directory to hold my transfers. So the location where I'm transferring all the files. CP. After copying all the configuration files and cold backup to the standby server, now we need to move the configuration files to the appropriate location. So now let me take the init.vara to the corresponding location. I'll copy vara file to Oracle home dbs, and the SID here is sbyORCL. So copy it with sbyORCL.vara file name. Now I also need to copy the password file. So the password is here, and I need to copy it with the SID name. So the SID is sbyORCL. Okay. Now I need to modify init.vara parameter so that it can be configured for physical standby database. I already have the configured init.vara file, so let me copy from the location and let me copy it with the name. Okay. Let me verify the values that we need to edit on the standby side. I think, yeah, it is init sbyORCL.vara. So these are all the values that I need to edit on the standby side. Now if you observe, the log file name convert and the db file name convert, I need to have the different directory structure on the standby side. It's not mandatory that we need to have a different directory structure. We can have the same directory structure that I have on primary side. But for the demonstration purpose, I want to show you physical standby side. So let me create those directories. Now I need to copy the standby control file to the appropriate location that I specified in the init.vara parameter locations. So my standby database control file is in the location, in the temporary location. Let me take that. So now I'm copying to two locations. The second location is this one. Now the standby control file is copied to the appropriate locations. Now configuration change that is required to create listener.vara and tns names.vara. So let me do that one. So let me first move the existing one. So I'll copy from the backup location. Now I'll show you the content for these files so that you can also have these same structure on your physical standby database server. So this is the listener.wara file, and this is the TNS name file. This is the same file that we had on primary database server. Now let me start the listener. Now also let me also test alias names. So both are resolving to proper listener. Also test in previous test we had um, SBI or CL failed, but now let me see. Earlier when we tested it is giving no listener. Now I'm able to successfully resolve this SBI or CL on the database side. Now let me go to the standby side. We now have the init.vara parameter for standby database. So I need to create SP file for this. So let me create SP file on the standby side. So now we have SP file created on the standby side. Now we are going to verify finally before proceeding the actual physical standby steps. We will verify whether all the configurations that we have done are perfect or not. Now from the primary side, let me verify one by one. So I need to be able to connect both primary and secondary side. So let me test it. I'm able to connect. Similarly, I need to be able to connect to the server aliases. This is the one. So I'm able to connect. So let me do the same as on the standby server. I'm able to connect. So with this I'm able to connect to both primary and standby from the primary server, and from the standby server I'm able to connect to the actual.